Okay, guys, welcome back. Up next is Stefan Kooman from BIT, with one bit to rule them all.
Okay, thank you for staying and for entering this room. My name is Stefan Kooman. I'm from BIT. And we're using OpenNebula to run our clouds. And I'm gonna explain how I've set it all up and how we're using it. And I hope you find it interesting. If you've got some questions, please leave them to the end. I will probably need all my time just to get through all the slides. So here we go. So who are we? We are an ISP in the Netherlands, just focused on businesses, so business to business. We try to deliver high quality network and IT infrastructure. And the way we do that is to operate our own data centers, operate our own network infrastructure, and be able to control every single part that makes the service available from the data center, from emergency power installations, cooling, all that kind of stuff, up to load balance server. So reliability is actually the main focus. Redundancy is keyword. We try to avoid single point of failures at all costs. So we operate our own data centers. We are based in Ede, in the Netherlands, a little city in the center of the Netherlands. And we've got routers at the Dutch internet exchanges, and in Germany and in England. We have IPv6 available on all services since 2004. Started implementing IPv6 in 2001, and got all our services running since 2004. So it's actually a hard requirement. If we have a new service, it should be available on IPv6. Besides that, we have ISO 27001 certification on all services. So it's the data center part as well as all our managed services. So how does our network looks like? We got 2 data centers in Ede. They're like 400 meters separated from each other. We've got a point of presence at Telecity 2 in Amsterdam and in Sarah. We connect with M6. Got a router at DECX and one in Telhuis North and Links. And we've got 3 transit partners, and we've got around 900 peers. On top of that network, we provide all kinds of services, access services, Ethernet, fiber services, VPNs, MPLS, all kind of networks. So why would you choose us instead of another cloud provider or a public cloud? Well, customers want to know where their data gets stored. So we make sure the data gets stored in our data centers, and we're not going to put it somewhere else. Especially after the Snowden era, you can say. The privacy concerns grew with our customers, so they want to know for sure that the data is stored in our data centers on Dutch soil, and also for compliance reasons. We provide an alternative for shared hosting, so people just want to have their own virtual machine to run some special application that doesn't fit into a shared hosting environment. For example, a special framework we don't support, or people want to have a Memcache server or so, and want to have a separate server for that. You can have a hybrid solution, so you can just bring your own servers and you can mix them with virtual machines from running on our cloud. Some customers want to bring their own firewall infrastructure, bare metal, but they do want to have virtual machines. So all those kind of combinations are possible. They like the availability we provide and the data redundancy, and the ISO certification is on a lot of lists. So what runs in our clouds? We do we have web shops, mission critical servers for small business infrastructure services. So small companies just bring everything to the cloud. Monitoring services, Singa, actually all kind of things. Well, I had to mention MongoDB because no presentation is complete without mentioning it. I learned that from Carlo De Fara this morning, so here it is. I can check that box. So I can stop right now, I think. I'm gonna take a nip. Here we go. So why did we choose OpenNebula in the first place? Well, actually, I think I've gone for some tweets, and I think almost everybody likes the simple but powerful powerfulness of OpenNebula. We tried different cloud management platforms, but well, and especially OpenStack, but it was a hassle to set up. It just cost us days just to get the understanding of how it actually is supposed to work, and well, then we installed OpenNebula and just worked out of the box. So yeah, we went with that. It's reliable. It hasn't questioned us once, so I would call that reliable. And it's been running for a few years. First in the test setup for quite some time, but production for a little bit more than 1 year now. Well, it has API interfaces to talk to, so that makes integration with our own infrastructure easy. It's open source software. That's pretty important for us. We use a lot of open source software, actually as much as we can. Most of the times we get forced by customers that they want to use some proprietary operating system, but we try to avoid that ourselves. Last but not least, it's a great community. Nice to have you all on the mailing list. Provide support to each other, and the devs are really great. They're really responsive. They listen to your questions. They actually try to think with you and provide solutions. So, well, thank you. So how does our cloud setups actually look like? Well, we got 2 data centers. And like I said, we don't want to have single point of failure. So we have like a twin data center setup. Bit 2 up front, bit 1 in the bottom. They're separated like 400 meters from each other, and well, we use F5 for load balancing. The front end are actually virtual machines running on the host. We have high availability setup, manual failover setup, I have to say. Actually, I don't know if you can read it. I think the text is pretty garbled. So we are using MySQL master and primary master. Use Apache with Fusion Passenger, known as Raptor nowadays, I believe. And we use Apache as a reverse proxy to reverse proxy requests to the OpenNebula daemon. So these machines actually run on the host themselves. It's connected to a Cisco top-of-rack switch. And all of that is running from NetApp NFS storage in a Metro cluster setup. So every write done in one data center gets written on the other synchronously. Our customers connect through our portal, and well, we use Sunsun as management as well as the CLI tools. We don't expose Sunstone yet to our customers because we think it's well, it used to be quite complicated before the cloud view was there. So then we took a different approach. We started simple, but I will talk about that a little bit later on. So cloudy, you know, we've got like 3 different clouds. We started with our customer cloud. A lot of demand from customers. They didn't want to have bare metal anymore. We would start asking them all kinds of questions: how much memory, how much disks, what should the configuration look like? They just want to have a server and start running, and then don't want to wait for 3 or 4 weeks before the server would actually be delivered. So, well, virtual machines make sense. So customer cloud first, then eat your own dog food. We made our own cloud. And of course, you have to do tests, and we made a test cloud. Well, it also has to do with security reasons. Well, worst case scenario would be a virtual machine escape attack. You could actually break out of your virtual machine, and then if you would have a shared infrastructure, then you will compromise your own network, your own services, as well as your customers. So we would try to avoid that at all costs. So we have separate VLANs, separate storage, separate servers, and shared nothing, actually. Well, and to avoid breaking production while exploring new features in OpenNebula and trying new setups and all that kind of stuff, well, we have a test cloud. So how did we get, actually, how did we do the migrating? Well, before, we just had ad hoc management of several KVM servers spread all over the place, and we would manage them with Thread Manager. We we would mix BIT and customer VMs. We didn't have a whole lot, but no, the ones we had were just mixed with our own virtual machines. We didn't have an overview of the amount of resources we are actually using. We had some scripts to get some info and to do some rough calculations, but it's not as nice as the dashboard view in Sunstone. And it is important for capacity and business continuity planning. And we didn't have any integration with our, with BASE, how we call it a bit, administration and configuration engine. It's actually a CMDB, configuration management database. Everything that we do is stored in there. So billing, technical stuff, all the data center, all the racks, all the connections, all the network, everything ends up there and gets connected somehow. So we had to connect our virtual machines with that system. So after we actually did that, we got all VMs centrally managed. We got the integration. We use hooks for that, and we used the XML RPC interface. We actually ended up with a web interface, so we could do remote management without need for VPNing into our systems and starting vert managers and all that kind of stuff. Especially when you're on duty, you wake up, you get a call at 2 o'clock in the night. It's easier to just go to a web browser and fix some stuff than do all other kinds of setup just to access the servers. Okay, so how did we actually migrate our own stuff? Actually, fairly easy. We got like 2 kinds of different servers at BIT. Non-PXE based virtual machines that are actually managed by CF Engine. We just created templates based on the old libvirt XML, did some dumps, created images. Well, then you wait, get some coffee and do DD, destroy an old, and then define the old VM and instantiate, and you're there. Because storage is most important, and that's actually the only thing that makes a server unique, really. As far as the infrastructure goes. So then we have got another class of virtual machines. So it's the PXE booting virtual machines. They get bootstrapped all by themselves. You just turn them on, they get their configuration, and they will just bootstrap themselves and install themselves and configure themselves, and they are finished actually fairly quickly. Much quicker than bare metal, actually, because you can skip through all the BIOS and post updates and the things that takes like 10 minutes from bare metal, and within 10 minutes the server is already done. We have got virtual machines that are bootstrapped within 5 minutes. For example, spam checking machines, they're almost finished in 5 minutes. So then it's even easier. You just shut off the old virtual machine, recreate it at the new in the OpenNebula cloud, and you're done. So while you're at it, you can actually get rid of some old machines. We had some old servers that we virtualized, so you can get rid of your junk. And well, we used to have a lot of Sun servers, so we are actually throwing those away as well. So goodbye junk, goodbye Sun. Welcome to a bright cloudy day. So when I was actually writing this, I was like, well, you're talking nonsense. You're drunk, go home. And then yesterday, actually, I realized that you can have both, but you just have to do it on top of the cloud. And that's what OpenNebula actually is. OpenNebula is on top of the cloud, and then you can have a bright, cloudy day. So, and we are happy OpenNebula users, so well, you can have both. That's okay, integration. Like I said, we have a portal interface for customers so they can easily manage all services, DNS, mail, and monitoring, billing stuff. But we also have a virtual machine management tab so they can, well, for now only stop, start, and reboot and have out-of-band management, console access. But actually, what most customers want is enough for them. But in the future, we want to have full-thread provisioning, monitoring, metrics of the virtual machines. Actually, all things you can do with a virtual machine. Create, destroy, clone, resize, live migrate, whatever. So we use NetApp NFS storage, and we use the multiple data stores feature a lot, like it a lot. And we use NetApp Q-tree feature to make a separation between customers. And a Q-tree is like a directory in a volume, you can say, with some special properties. It's not really special, just some NetApp thing. But you can have quota on these Q-trees. And you can also have, you know how much IOPS each volume or actually each Q-tree is using. So you can use that for billing. So this information is not available in OpenNebula yet. You don't know how many IOPS are used by the virtual machines. So, and actually, IOPS is what we say, the gold in the cloud. Capacity is not the problem. It's the amount of IOPS VMs consume. So you actually have to have a billing model. At least that's what we believe. It makes tiering possible if you have multiple data stores. You can have a SES tier or a hybrid pool. You can just split VMs according to workload. Some things better fit on SES disks. We have the application turned on the NetApps, and we find that we have a saving of 41% on customer images and around 61% on our own images. We got some more similar images running. But in the future, we will be looking at distributed object storage. Probably it's going to be Ceph. It's really promising. And as soon as we build another data center, then you can actually make high available Ceph cluster, where you can have 2 data centers surviving when 1 data center gets down. But it's something that's going to be done in a couple of years. We first have to build another data center, and then we can have such kind of things. For monitoring, we are using Isinga nowadays. We used to have Nagios. We're switching to Isinga, and we really, really like it a lot. It's really, really awesome. So we're actually in the process of migration. We use active checks on the front end. We made our own monitoring daemon. So it's running on the hosts themselves, or the VMs, and it's talking to a live status API and submitting all the checks, and then it gets handled by Isinga. The advantage of having a local agent submitting stuff is that you have all the software installed on the machine already that you want to monitor, Ruby libraries or Python libraries or whatever. You can just use the software that is installed, do all kinds of checks, even with root privilege if you want to, because you're just going to submit it. You're not going to allow any requests coming in. You're just going to submit. So that is actually pretty nice, working really flawlessly. So we will check Vital1 functions, OpenNebula daemon, VM status, data stores capacity, etc. And of course, our hypervisor hardware network bonds that you're actually check that you're still redundant until you actually figured out that you're not redundant anymore. Passive checks are still there. We use them to check our web services. Well, and during testing, a colleague of me is on top of Isinga, and when I'm live migrating a virtual machine, he will actually discover within 1 minute that I did a live migration because you have a time skew, and NTP gets out of sync, and Isinga will notice within 1 minute. So actually, we are seeing much more issues on virtual machines and hardware and networking that we haven't seen before when we were using Nagios, just because Isinga is that much quicker. So that's really nice. So yeah, we use Simulian for graphing. I think graphing is important to have understanding what's going on. You have a baseline of your infrastructure, and we just try to graph as many metrics as possible, just because we can. But also, sometimes when strange things are happening, you will get information from metrics you never thought you would have used otherwise, but are actually giving you a clue what's happening. So that's why we catch a lot of metrics. So for operating system, applications, storage, network, everything. Easy for trend analysis, so you know how much VMs you can still provision on your infrastructure. And it's nice to find performance issues. For example, you had a customer that was using only like 200-300 IOPS per second, and then all of a sudden they had an issue, configuration issue on all of their VMs, like 50 VMs or so, and they started sequentially logging all of the same time, doing a lot of encryption and spending a lot of I/O cycles. And actually, our disks got 90% busy, and they didn't like that a lot. Actually, the other virtual machines on the platform didn't like that. So you will want to know what's happening. And because we have these different queue trees, you can actually see what customer is actually getting all those IOPS and act accordingly. So then the total amount of IOPS a virtual machine is actually able to perform is really useful. So you can just reinstantiate, cap them, and well, you can at least isolate or handle the problem without shutting down the virtual machine entirely. So we do use accounting. We do get accounting information from OpenNebula, but we use the VM monitoring actually to get the network's traffic. We're not using the one act because we need to have much more network traffic info than the accounting is giving us, and it's giving us a bunch more that we don't need. So it would actually just have like poll often, so we can actually do our own calculations based on volume, but you can also have like a commitment, like a 10 megabit range for all your VMs or certain VMs, and then you actually have to do some calculations. And we do stuff with percentiles, so you can actually burst, and then we won't charge you the whole amount, but you have to do a lot of calculations. So we just pull all that information from OpenNebula and crunch them in our own system in base. So up to now we have like a 3 monthly contract system or a contract with our customers, but we could change a pay-per-use on virtual machine because OpenNebula is actually accounting when the virtual machine gets started, when it gets shut off, when it gets resized, so you can actually bill on that information. So we might change this this billing model for virtual machines. So there are tons of features. Actually, I have to see how much time I've got left, because there's some slides left. One of the features I like a lot is filtering with the scheduler from OpenNebula. You're actually able to enter certain requirements into your virtual machine templates, and you can filter on data stores, clusters, or hosts, and you can invent your own attributes, which is really nice. So we use a couple of requirements. For example, we want to have Windows virtual machines landed on hypervisors that have that are Windows licensed. So we know for sure that we are compliant. They will all automatically provisioned on the right hypervisor. If we want to have a virtual machine being executed in a virtual in a data center, we can just set a requirement that it should be deployed in a data center, and it gets there. And because we're using the multiple data stores, and we are actually using multiple system data stores as well, you want to make sure that a virtual machine gets operated in the system data store which the customer owns. Otherwise, the default policy of OpenNebula is that it will just use all the data stores at random, or actually tries to load balance, but that's not what you want. Otherwise, you might bill customer A for IOPS that customer B actually performed. So this is a hard requirement for a VM template. So we've got hooks. We've got the notify running hook. As soon as a virtual machine gets running state, enters running state, we'll send a hook, and we do an XML RPC call. We actually register the virtual machine in our configuration management, or we will update the information on where it is. So if we do a live migration of virtual machines from data center 2 to data center 1, it will automatically gets updated in our management database. So you always know where a virtual machine is actually living. We've got another one. It's St. Carthusius ARP. We've got several layers of switches, and then you can have issues when you're actually live migrating a virtual machine from one data center to the other, and then the switches have to actually update the forwarding table so they know where to send the frames to the right switch. So we will send out the Cartouche ARP just to make sure the routers and the switches update their forwarding tables. And if you're actually doing a physical to virtual migration, then the routers need to update their ARP cache as well. So, but it's only needed if you are actually changing MAC addresses. Well, there's this Open vSwitch ARP cache poisoning prevention rules, which are really nice, especially in the public cloud, where you can trust users. But it also prevents high availability setups from working correctly, because you will have virtual MAC addresses. If your P-carp is using vHIT's virtual MAC address, and it's not, and it doesn't. There's no open flow, or there's no flow configured for that MAC address on the host. So we'll just silently drop all the frames, and then your HA setup isn't working correctly. We will have two masters competing with each other. Both think the other node is dead. So we'll have to need to fix this. Actually, this is a hook in progress. I'm working on this one. So it's easily hackable. We once had the question, we want to migrate over a dedicated link. We've got the dedicated link between our two data centers just for live migration. And we didn't want to do route all the, or move all the traffic through the other upstream switches. So we want to have over dedicated network interface. And it's really easy to just add another host name in your DNS, put another label in there, have this network interface configured a different IP address, well, change a few lines, and then you just move stuff to a migration host, which is actually the same host, but reachable over a different network. So now we can migrate all the virtual machines over a dedicated link. And if that's not available, we will fall back to the default based on VLAN priority. Okay, so we've got some clouds from for some Kerio virtual machines running at BIT, and we're working on automating and speeding up the provisioning process. So we are working on using the one XML RPC to clone a contextualized golden image and to configure the Kerio by its API, and some operating system specific things later on with OneGate. So you have got an asynchronous communication channel, and you can actually have the virtual machine change things according to stuff that is being changed in the template of the virtual machine. So OneFlow is also quite interesting. It's yet to be implemented, but we have been testing our filtering and spam checking setup. We've been doing sizing. As soon as there were virtual machines, we wanted to know how much load can we handle, how much spam email can we actually filter. So how should we size? And then we figured out that the CPU as an indicator alone is probably not enough, because if you would scale up too fast, then the hypervisor is not going to scale up. The CPU frequency scaling is not doing its work. So you actually have to stress a virtual machine to 100%, then you have to stress it some more, and it's going to do much more. It's still 100%, but because the CPU scaling is kicking in, you can actually process much more. So you want to make use of the vertical scaling of the CPU frequency scaling of the hypervisors, and as soon as you got that maximum, then you will want to scale horizontally. But otherwise, you're just provisioning new virtual machines, where you can actually just let the CPU frequency scaler crank the CPUs. Well, it should work well in a load balanced environment. So somehow we have to integrate it with our F5 load balancers. So there's some work to do, and some tuning as well. So some lessons we learned, do's and don'ts. Set the fixed machine type in QEMU when you're using Windows. As soon as you upgrade your virtual infrastructure, Windows thinks, oh, I see new hardware, I will just stop working. Although it actually has all the drivers installed, but it will just detect it as new hardware. And you actually have to tell Windows it has to boot in a certain mode to actually rediscover all the drivers and just go fix itself, but it won't by default. So if you just upgrade and reboot your virtual machine and you don't have a fixed machine type, you'll break Windows. So you want to avoid that. We'll use Virtio whenever you can. We did some performance tests with pfSense, and we would get 1 gigabit of throughput versus 300 megabit on Intel. So it is quite a substantial difference. Group virtual machines together that are actually communicating a lot, like web servers and database servers. So if you're not building redundant setups for customers, you just want to have all these virtual machines on the same hypervisor. So you save intros bandwidth, especially when you're limited in bandwidth. You will want to cluster. So it increases performance and it lowers latency. Most of the times you don't want to expose CPU flags in order to avoid live migration issues between different architectures and different versions of CPUs. But sometimes you do need them, you do want them, especially in high performance clouds or in rendering. We've got a customer that is using our infra to do render jobs, and he needs certain CPU flags to be enabled. So we actually expose those flags for him, so he can make use of it. And if you really need every CPU cycle, then you should disable kernel same-page merging. Those two things together can actually give you a 15 to 20% performance increase on your CPU-intensive job. So it's if you're doing if you're having a render farm with lots of nodes, then 10% or 20% actually is quite a big percentage. So here's an example. Throughput you're actually able to get. You can get 2 gigabytes per second on the same hypervisor. That's like 7 gigabit. So that's quite a bit of traffic you can do between virtual machines on the same host. So how am I doing time-wise? We're done. Yeah, so it's something like I thought. I'm gonna speed it up. So we also have a test cloud. We're testing a bouquet switch nowadays. Currently, basically it's the same setup as the production cloud. Fast Ethernet actually does have a performance increase when you do live migrations. You're not getting 10 gigabit speed or 20 gigabit speed, but you actually get 600 megabytes without tuning. So it's already a lot faster, but still there's some tuning to do. And it would be nice if we could have OpenNebula manage the VLANs on the switch itself, but we have to make sure that we can lock down the user that we are using on the switch to prevent any nasty things from happening on the switch itself. Otherwise, that's the way to kill your network. Challenges. Yeah, we would like to be able to administer all IPs into OpenNebula. For example, to have IP aliases for web servers that are doing SSL or actually TLS nowadays. And if you want to make use of the anti-spoofing and anti-IP hijacking OpenFlow capabilities, then you actually need to administer all IPs. Otherwise, you don't have the right flows enabled on your host, and you're not able to do any traffic on those IPs. So it's actually essential if you want to make use of it. You do have to make some contextualization adjustments just to need to handle the extra IPs. SDN is something you have to think about it. The future. Actually, I was quite surprised. OpenNebula is really good in interfacing with other clouds. There's an interface for Azure, for OpenLayer, or for OpenLayers, Azure, SoftLayer, and Amazon. But it's quite humble, but it doesn't have a native interface to talk to itself, which is actually quite surprising to me. And I envision a future where we are actually connecting our clouds and to have something like a cloud exchange, for example. It would be much easier to use spare capacity from partners, partner data centers, or customers. Some customers might have their own OpenNebula infrastructure, but sometimes they want to burst to yours. So it would be nice if they could just enable your cloud in their cloud instead of having having to go to another public cloud, especially if you don't want to store your data somewhere else. Okay, I'm almost done. Tino asked for a Christmas request list. We have Sinterklaas coming up in the Netherlands on 5 December. It's a national happening. So this is my feature request list. Some stuff on here that I would like to see implemented some point in time. But I will just want to thank you for implementing the features that are already in: multiple data stores, federation, clone between data stores, VLAN trunks, address ranges, and tons of other things that are actually implemented. But there's still, new stuff that would be cool to have inside OpenNebula. So I will just shut up now and wait for questions if there are any.
Thank you, Stefan.
Sorry. So, yeah, there's one more left. So thanks for having me, and NETWAYS for organizing.
Thank you, Stefan. Any questions for Stefan?
Since you are a service provider and you're actually using OpenNebula, it was very interesting. Can you tell me what happens when a server goes down, a server box goes down, whether it's a compute node or a storage node, the real mechanism? What are you depending on to provide a continuous service to the customer?
Well, we don't have this automatic failover, because if you only have like 2 data centers, you can never make sure you're not ending up in a split brain situation. And so there's always a manual intervention from an engineer, and there's a guy that is actually, it depends on the situation. If a whole data center goes down, you have to make a calculation if it's going to be back online within a certain amount of time. If it's only a hypervisor issue, you can just start the virtual machines at the other side. But it really depends on the situation. Some situations you will have to do a manual takeover or storage-wise on the other infrastructure, because if it would, the data center would be completely destroyed. That's actually the worst-case scenario. There's a thing you have to do as a network engineer to actually force a takeover of the other node, and that's something you have to do by yourself. It's not done automatically. It's manual. Yeah.
One of the server boxes is having a big
We have. Yeah.
what happens?
Well, we got alerted. Well, and Isinga's going to call us, actually through Asterisk, and then we will just start the virtual machines at the other side. That's the easiest thing. I mean, if the storage is still available, well, live migration is not possible because the node is dead. So we will make sure the node doesn't get up. We'll kill all the virtual machines if the host is in some weird state. So we'll just power it off, make sure it's not going to get up again. And then we'll just restart the virtual machines on the other side. So we advise customers who have like high availability to have 2 virtual machines at least, one running in data center one and one in the other. Otherwise, you can't guarantee that you will still provide service when one node goes down. So if you really need continuity, just make sure you.
They have to opt for high availability if they want.
Yeah, sure. Yeah.
Is
Yeah, sure. Yeah. Then. Yeah. Yeah, sure. Then we will. Yeah. We always advise people to put more. Don't put all our eggs in one basket. So yeah, just spread it across data centers. That's how we do all our services ourselves as well. It's all split into the 2 data centers.
Do you use some kind of fencing or storage mechanisms?
No, we don't use fencing because because we don't have this automatic failover in place. So it's an engineer who's gonna do the fencing. So actually, the fencing is manual.
It's a manual process.
Yeah, actually, if you want to do those things automatically, then you would have like a third data center or a third location, like as a tiebreaker that has to make decisions on which data center is actually surviving and what to do with the other. But if you can't reach this other data center, what are you going to do? If it's coming back online, So
It's a Kooman decision. It's right.
Yeah.
We have modified the host error hook to fence a host by a call by IPMI or ILO module to shut down the server. And after successful shutdown, we instantiate the VMs on the surviving host.
okay, so you actually, and otherwise, what are you gonna do? If you don't get an acknowledge because this machine is dead?
It's will a problem, yes.
Yeah, yeah. So it's yeah, it depends on the situation, but you actually have to make sure that the node is dead and it's not running. Otherwise, you have instant data corruption. I did some stupid things in the past, actually not that long ago, just manually defining a virtual machine, and I just reinstantiated the same virtual machine, and I'll just kill the virtual machine. It was just the test virtual machine, so it didn't matter that a lot. But I mean, as soon as you're doing manual stuff, then you have to take care. So, any other questions? Uniscale. We just throw hardware at the problem. We just bought a big box and we put SSDs in it. So the Muni is actually a single point of failure. We do back up the data, but it's it's really it's difficult to scale. So we just threw some hardware at the problem. It's not super critical if we lose that. I mean, it would be inconvenient, but it's not, and we could recreate it. We will have backups of the RODs that being generated, but no, well, it's a good question.
Anyone else? Okay, thank you, Stefan.
Okay.